faster than the fabric of space-time can keep up with it, and it'll just rip, and I'm terrified by this. Currently, our night sky is changing rapidly, and in just a matter of decades, if not years, it might become completely unrecognizable. Astronomers worldwide are sounding the alarm. Experts like Neil deGrasse Tyson have recently confirmed the imminent explosion of Polaris, and the tale behind it is quite frightening. Polaris, known as the North Star, has long been a constant in our night sky, serving as a crucial reference point for stargazers, navigators, and astronomers. However, this might soon change, altering our night sky and astronomical measurements indefinitely. Let's delve into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris as it approaches its end. For centuries, Polaris has guided mariners and astronomers alike, holding a revered position as a guiding light. Its unwavering presence in the night sky has been essential for navigation, but this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial luminary. Polaris is on the brink of exploding, potentially vanishing from the night sky forever. Before we explore the consequences of this revelation, let's understand more about Polaris, also known as the North Star or Pole Star. Polaris is special due to its proximity to the celestial North Pole. Situated almost directly above Earth's North Pole, it appears almost stationary in the northern sky. Found in the constellation Ursa Minor, or the Little Dipper, Polaris shines as a moderately bright yellow-white supergiant star, much larger and brighter than our Sun. It's not a solitary star but part of a complex triple star system, with Polaris A and Polaris AB forming a binary pair, while Polaris B orbits around them. The interactions among these stars create gravitational forces, shaping their orbits and influencing their behavior. Any disruptions in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years away from Earth, meaning the light we see from it today started its journey over 3 centuries ago. Thus, if Polaris were to explode now, we wouldn't observe it until over 3 centuries later. It's even possible that Polaris has already exploded, and we're yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its stability and fixed position made it an invaluable aid for ancient navigators, guiding them across seas and lands. Symbolically, Polaris represented constancy and guidance, remaining steadfast amidst the ever-changing night sky. For astronomers, Polaris served as a crucial reference point, aiding in the study of celestial motions and variable stars. As a Cepheid variable star, its periodic variations in brightness have provided valuable insights into stellar properties and the nature of variable stars. This characteristic also played a pivotal role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, which has been the norm for the star, making it easy for us to anticipate its behavior. However, recently Polaris has strayed from this expected behavior. This irregularity in its pulsation cycle has puzzled astronomers, leading to a closer examination of this celestial anomaly. Instead of its usual predictable pattern, Polaris has begun displaying erratic cycles of dimming and brightening. Scientists are now raising concerns that the star may be approaching the end of its life. This aligns with behaviors typically observed in stars nearing their end. The gradual elongation of Polaris's pulsation period, which was once stable, can be attributed to interactions within its star system. We've observed an annual increase in the pulsation duration of 4 to 5 seconds, which might seem insignificant but holds significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these fluctuations in its atmospheric conditions, directly affecting its pulsation patterns. However, others are more alarmed, believing that the star is on the brink of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another notable star in the Orion constellation, are striking. Both stars have shown perplexing irregularities in their luminosity, raising concerns about potential explosions. Cepheid stars in their twilight stages often exhibit such irregularities before reaching the culmination of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention hasn't been officially directed toward Polaris yet. As a Cepheid star nears the end of its life cycle, it progresses through various phases, including the main sequence phase, red giant phase, and ultimately the supernova explosion. Based on Polaris's irregular pulsations, scientists predict it has entered the stages of helium depletion typical of Cepheid stars nearing their end. These irregularities in Polaris's behavior align with patterns indicative of Cepheid stars in their twilight phases, but definitive indications of its nearing supernova remain inconclusive. Astronomers are diligently analyzing these irregularities to understand Polaris's fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, potentially outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance might drastically change, temporarily altering our perception of familiar constellations like the Big Dipper or Ursa Minor, of which Polaris is a part. Rest assured, the Earth would likely be perfectly safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion might not be as visually spectacular as that of Betelgeuse, it could still be visible to the naked eye for an extended period and outshine nearby stars. Astronomers and observatories would undoubtedly take notice, sparking intrigue within the scientific community and among stargazers worldwide. However, the specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing. While giant stars typically end their lives with a supernova, this is unlikely to be the case with Polaris. When a massive star goes supernova, a massive explosion occurs within it, marking the final cataclysmic stage in its life. This process involves a complete collapse of the core, triggering an intense shock wave that causes the star to explode violently. However, Polaris is not massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transformation won't result in a supernova, but rather a serene conclusion as it evolves into a small, extremely dense stellar remnant. A white dwarf is the remnant of a low or medium-mass star that has exhausted its nuclear fuel. It's incredibly dense, about as massive as the Sun but compressed to the size of Earth. When this happens, we will no longer be able to see its remnants from our planet, much like we observe the star today. Comparing the anticipated effects of Polaris's burst with historical supernova occurrences provides valuable insights into the evolution of stars and their ultimate fates. Comparing our expectations with well-documented supernovae like SN 1987A and more recent events such as SN 2011 Fe or SN 2014 J provides valuable data for understanding the potential aftermath of Polaris's burst. SN 1354, for example, resulted in the formation of the Crab Nebula, a nebula that continues to expand and emit radiation across multiple wavelengths, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into the processes of nucleosynthesis and the dynamics of supernova remnants. Analyzing phenomena such as the formation of nebulae, the release of cosmic rays, and variations in luminosity can offer insights into Polaris's unique characteristics. The formation of nebulae like the Crab Nebula results from the expulsion of material during the supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Additionally, the release of cosmic rays, high-energy particles accelerated by the supernova shockwave, has implications for astrophysical processes and cosmic radiation environments. To make a definitive comparison, scientists evaluate differences in mass, composition, and speed of ejected materials between Polaris's anticipated burst and other observed events. This involves studying the light curves, spectra, and remnants from these events and projecting similar characteristics for Polaris's anticipated burst. Assessing whether Polaris's burst might lead to the formation of nebulae or distinct elemental distributions enhances our understanding of its potential outcomes. Another crucial area of investigation involves evaluating the pulsational variability of stars nearing their end stages, akin to Polaris, against observed supernova precursors. This comparative analysis can help gauge similarities or deviations and provide insights into the burst mechanism. Pulsational variability in stars nearing the end of their lives may be indicative of internal instabilities or impending catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Despite meticulous observations and extensive analysis, astronomers find themselves puzzled by the irregularities observed in Polaris's behavior. Unraveling the unique conditions driving these irregularities holds the key to advancing our comprehension of stellar evolution. Understanding the mechanisms responsible for Polaris's irregular pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a crucial reference point in the night sky poses substantial concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, impacting the accuracy of astronomical assessments. The absence of Polaris could also affect navigation systems and cultural practices reliant on celestial landmarks, underscoring the significance of this celestial event. The enigmatic behavior exhibited by Polaris underscores the necessity for deeper investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding its irregular pulsations and present concrete answers, recognizing the importance of advancing our understanding of celestial intricacies. Ultimately, the answer to Polaris's fate remains uncertain, and only time will reveal its true nature. Nonetheless, the pursuit of knowledge and understanding in the face of cosmic uncertainty is a testament to the enduring curiosity of humanity in unraveling the mysteries of the universe. As we consider the fate of Polaris, it's essential to recognize its role not just as a celestial marker, but as a window into broader astronomical phenomena. The North Star has been pivotal in humanity's understanding of the night sky. Ancient cultures utilized its position to develop calendars and seasonal agricultural practices, linking celestial events to earthly activities. As civilizations advanced, Polaris's stable location offered navigational aids that facilitated exploration and trade, marking it as a cornerstone of maritime history. In modern astronomy, Polaris serves as a key calibration point for telescopes and observational instruments. Its consistent brightness has allowed astronomers to refine their measurements of distance across the cosmos. The star's predictable light output contributes to the cosmic distance ladder, an essential tool for gauging distances to far-off galaxies and understanding the expanding universe. Interestingly, the study of Polaris also opens avenues for exploring stellar evolution. By examining its life cycle, scientists gain insights into the broader life cycle of similar stars. The properties of Cepheid variables, including their pulsation periods and brightness variations, allow researchers to draw comparisons with other stars, enriching our understanding of stellar characteristics across different phases of life. As we explore the end stages of a star like Polaris, we must also consider the implications of its eventual transition into a white dwarf. This process is a fate shared by many stars in the universe, leading to the formation of stellar remnants that will linger for billions of years. The study of white dwarfs has important implications for our understanding of stellar and galactic evolution. Moreover, the interaction between dying stars and their environments is a fascinating area of research. When stars shed their outer layers, they contribute to the interstellar medium, enriching it with heavier elements formed through nucleosynthesis during their lifetimes. This recycling process is critical for the formation of new stars, planets, and ultimately life itself. By examining the remnants of stars like Polaris, scientists can trace the pathways of matter through the universe. The potential explosion of a star like Polaris raises questions about its impact on the surrounding celestial environment. While its distance from Earth offers a layer of safety, the energetic phenomena associated with supernova events, such as shock waves and the release of high-energy particles, can influence nearby star formation processes. This can lead to regions of intense star formation or trigger the collapse of gas clouds, resulting in the birth of new stellar systems. In addition to its scientific implications, the narrative of Polaris touches on philosophical considerations about humanity's place in the universe. As our understanding of stellar life cycles deepens, we are reminded of the transient nature of celestial bodies. Just as Polaris has guided humanity for centuries, Its eventual transformation will mark a shift in our night sky, serving as a poignant reminder of the inevitable changes that permeate the cosmos. Astronomy has often inspired questions about the future of our planet and species. As Polaris approaches its eventual fate, it encourages us to reflect on our own existence and the legacy we leave behind. The pursuit of knowledge about stars like Polaris fosters a sense of wonder and curiosity that transcends generations. Finally, ongoing observations and advancements in technology will allow astronomers to monitor Polaris more closely than ever before. Upcoming telescopes and space missions are designed to capture unprecedented detail in stellar behavior. These observations will not only illuminate the life and death of Polaris, but also enhance our understanding of the broader universe. In conclusion, the story of Polaris extends far beyond its immediate visibility in our night sky. It embodies centuries of human exploration, serves as a crucial benchmark for astronomical measurements, and invites us to ponder the deeper questions of existence. As we watch the fate of this revered star unfold, we participate in a larger narrative about the cosmos, a narrative that continuously shapes our understanding of life, time, and the universe itself.